Not till next quarter. Well, we're going to talk about that. First thing I want you guys to see is this is same thing. This is under solving radical equations because if you guys remember, we can write all rational powers as radicals. So the problem could look something like this. 2 times the cube root of x plus 3 squared equals 8. Would you guys agree with me? Same thing, right? Exactly the same thing. Now, the only difference is, so if I was going to solve this, again, the same step would be applied, right? What is the first thing you want to do? Divide by 2. Well, guess what? It doesn't matter, guys, if it's a rational power or not. The first thing you're going to want to do is isolate your radical or your expression raised to a rational power. So I have x plus 3 to the 2/3 equals 4. Now, if you were to write this in radical form, which is perfectly fine, there's nothing really wrong with rewriting it in a radical form. However, when you do that, what you have is now you have to undo the cube root, which would be doing what? How do you undo the cube root? Cube. So you'd have to cube both sides. Then you'd have to undo the squaring. So then you'd have to take the square root of both sides, right? So it's perfectly fine. You can easily do that. There's nothing wrong with that. However, exactly what Sahil said is if you're looking at this in rational powers, you can convert it over and simplify it that way. Or you can also raise this side to the reciprocal power. Because remember the power rule of exponents. The power rule of exponents says when you have an exponent raised to a power, what do you do with the powers? You multiply them. What's any number multiplied by its reciprocal? 1. So therefore, I no longer have an exponent on the left side. Pretty cool, huh? Yes? Yes? Oh, write down just write it down. X plus 3? Oh, yes, it is. Was that your notes? Why don't you write 3? Say 3. X plus 3, yes. Huh? Oh, it's OK. Now, here's where another thing that comes into confusion. If you guys remember, if we had the 4th root of x to the 12th power. If we had the 4th root of x to the 12th power, when we were simplifying this, if I would simplify this, the 4th root of x cubed to the 4th power. The 4th root of x cubed to the 4th power is just x cubed. Correct? One thing in 6-1 that I told you guys, whenever you have the even root or the even index, and your answer is a variable or an expression to the odd power, you have to use absolute value. Only time, whenever the index is even and your answer is to raise to an odd power, you want to make sure you utilize the absolute value. So in this case, some of you guys might be able to write this. You could either rewrite this as the square root of 4 cubed, or you could rewrite 2 as 2 squared to the 3/2. Whatever way makes more sense for you, it really doesn't matter. 4 cubed is what? 64. Same thing. 4 cubed is 64. What's the square root of 64? 8. Here, the 2's divide out. What's 2 to the 3rd power? 2 times 2 times 2 is 8. So 2 different ways to think about it. You could either convert it to a radical, or you could rewrite your base as an exponent and then use the power rule. Either way, you get 8. However, that's 8 to the 1st power, right? So therefore, this is going to be the absolute value. OK? It's all because this denominator that you use the reciprocal, it's all because this is even. OK? If this was odd, you wouldn't have to do that. So now, if you guys remember, in Unit 1, we learned how to solve absolute value equations. So therefore, in my case, I have x equals 5 and x equals negative 11. Now I need to go back and check my answer. And remember, raised to the 2/3 is the same thing as squaring and then taking the cube root of. So I have 5. 5 plus 3 is 8. 8 squared is 64. The cube root of 64 is 4. 4 times 2 is 8. Equals there. That works. Negative 11. Negative 11 plus 3 is negative 8. Negative 8 cubed is 64. Cube root of 64 is 4. 4 times 2 is 8. So guess what? I have 2 answers. And both of my answers work. OK? Anybody have any questions? Solutions. When an answer does not work, it's called extraneous, which I don't know if we'll get to or not, but or I'm not going to get to it.